Okay, everybody, here is the review on radicals or square roots, cube roots, whatever. So I just wrote the questions out. It really is, let me grab it real quick while I'm talking. Hold on. Okay. So it is, what I'm looking at is this review sheet, but I've just written the problems down, okay? So number 1, 5, square roots of 27x to the 8th, y to the 11th. I just broke 27. Then you can watch. This probably wouldn't be a bad thing just to watch while I record it, okay? So I broke 27 into 9 and 3. I want to take half the exponent, so I took half of that, made it x4. That's odd, so I made it into y10, y. So then square root of 9 is 3. I took half of that, I get y5. I can combine that. Oh, I forgot to combine them. Make that, wait a minute. That should just be a 15. I forgot the 15, that's a 15. x4, y5, square roots of 3y. There we go. Number 2, because it's cube root, I have to break it down a little bit differently. That's a perfect cube root, 27 and 2. I want to take a third of that, so I did. I took a third of the x9. I want to take a third of that, so what I did is made it into an x6, so I can take a third of it, and then an x left over. So then cube root of 27 is 3. I took a third of that. There's my x3. I'm going to take a third of that. There's my y2. And what's left over is cube root of 2y. All right? Number 3, I just multiplied it. I got 15 square root of 72, but I can break up the 72 into 36 and 2. Square root of 36 is 6. 6 times 15 is 90 times square root of 2. Now, you can pause this anytime you want. I'm just going to whip right through it, so pause if you need to, okay? Number 4, I foiled 12 square root of 25. Minus 4 square root of 5, plus a 6 square root of 5, minus a 2. Square root of 25 is 5. 12 to 5 is 60. I combined these two and made it a 2 square root of 5 minus 2. And then finally I combined the whole number 60 minus 2 to give me 58 plus 2 square root of 5. Okay? 5, don't let 5 be hard. It really is just the square root of 100 over square root of 9, which is just 10/3. Easy. Okay, 6. I actually divided it first, okay, because you can divide, because it's both inside, I can make it a 20, x7, y6. So then divided. To break it up, I got to break it up into square root of 4, square root of 5. I need to take half of this square root, so I made it an x6, x, and I want to take half of this. So here we go. Square root of 4 is 2. I took half of the x6 to x3. Took half the y6 to make y3, and what's left over inside is the 5x. All right. Again, pause it if it gets going too fast for you, okay? Turn the page. All right, number 7. So it becomes a square root of 7 over square root of 2, but the rule is you can't have a square root in the bottom. So I rationalize it, multiply top and bottom of the square root of 2, square root of 2, to give me the square root of 4. We know the square root of 4 is 2. Don't divide these. That's not really a 14. That's some ugly decimal number. That's your answer, okay? 8, if it's a fourth root, I found a perfect fourth root of 16 and 2. I'm going to take a fourth of this, so I broke it up into x4, x3, so I could take a fourth of it. And I'm just going to take a fourth root of 16. So, fourth root of 16 is 2. I'm going to take 1/4 of its exponent, make an x1. And then I'm going to take a fourth of 16. This exponent makes y4. And what's left inside is a fourth root of 2x cubed. Okay, 9. The rule is you're not supposed to add them, but maybe I can break them up if I try. Okay, so that's going to be 4 times 2. I like that because square root of 4 is 2. 2 times 5 is 10. Boom. 32, I break it up into 16, 2, because the square root of 16 is 4, and 4 times 4 is 16, okay? 18, I break it up into 9 and 2, the square root of 9 is 3, 3 times 3 is 9. Now, I can add them, they're all the same. 10, square root of 2 plus 16, square root of 2 minus 9, square root of 2 is just a simple old 17, square root of 2, okay? Can't add them unless they're the same. Okay, 10, I gotta solve. Well, all right. Minus 15, minus 15. Ooh, I get a negative 5. So I'm a little bit concerned this was not going to work. But okay, let's say I don't know that. Pretty sure there's no solution because of the negative here. So I work on it, square both sides, get rid of the square root. X plus 1 equals 25. Minus 1, I get 24. I'm like, wait a minute, this might not be right. So I checked it. Put the 24 back in for x. Okay, 24 goes in for x. 24 plus 1 is 25. Square root of 25 is 5. 5 plus 15 equals 10, right? What? No, 5 plus 15 does not equal 10. I knew there was no solution, but by checking it, I found out for sure there was no solution. So no solution, okay? The negative, I knew the negative was going to be bad. Okay, now, solving this one. So the only trick to this one is when you square both sides, don't forget the 2, you have to square the 2. Okay, so square it, square root cancels, square it, the square root cancels, but don't forget to square the 2, which makes a 4. Then I distributed, solve for x, minus 2x, solve for x, add 4, divide by 10, and I get 0.6, okay? 13, same thing, almost exact same thing, so I square both sides, but I remember the 4 needs to be squared, so I get 16. The square cancels squared. Now here, this is x plus 1 squared, which is x plus 1 plus x plus 1. I did the little foliage, first outside, inside, last. I combine the 2x, combine the 1x plus 1x, give me 2x. Then I'm looking at, wait a minute, I probably need to factor this because of the x squared. So if I need to factor it, let's set it equal to 0. So minus 16 minus 16x, minus 16 minus 16, and I wind up with having it 0. And this will factor x squared minus 14x minus 15 into negative 15 and 1. My mini equation is going to be a 15 and a negative 1. And I think both of these will work. I can just see that I'm not going to get any negative square roots. So okay. Okay, 14, I graphed the original square root of x in blue. And then I want to do translation. I wanted to move it to the right 4, remember it's the opposite side, and up 5, and then upside down. So here's my g of x, okay? The domain is x is greater than 4, and the range is y is less than 5, okay? 15, well, if I graph this parabola, it has a vertex at 4, negative 3. So I graph in the parabola, but I don't want to graph all of it because I know I'm going to have to make a domain change, okay? So the first thing I do is say, okay, let's make sure that x is greater than or equal to 4. So right here, at x equals 4, that gets rid of the back half. I have to get rid of the back half because then that gets rid of the bottom half of the inverse. All right, good. So then I switch it around. Instead of vertex at 4, negative 3, the new vertex is at negative 3, 4 for the inverse. And then I graph the sideways parabola. Don't want the bottom part, so when I find the inverse equation, f of x and y, I switch the variables, solve for y, add 3, square root, but not plus or minus because I changed the domain, and then I add 4. So my inverse equation is, f inverse is the square root of x plus 3 plus 4. Now the domain has got to be x is greater than or equal to negative 3, and the range is y is greater than or equal to 4. Okay, almost done. On the back side, here's my equation. It's a pendulum, and the longer the arm, the slower it rocks back and forth. Short arm goes pretty quick. So it's okay. Here's my equation. The time with respect to the length of the pendulum is 2 pi L, which is the length, divided by 9.8. Okay, that's just gravity. That's where that number comes from. So we know the length is 0.5. We want to find out what's the speed. So I put 0.5 in for L. I used my calculator. And I wound up with an answer about 1.42 seconds. Okay? So if you have any questions, ask me, but that's the review. I would suggest putting this into your notes because you can use your notes tomorrow, but you can't use your book, right? You can't use your phone, and but I would definitely put that in your